Welcome back everyone to Learning by Teaching. We're in statics and today we're going to do problem 624, okay? It says the maximum allowable tensile force in the members of the truss is 5 kilonewtons and the maximum allowable compressive force is 3 kilonewtons. Determine the maximum magnitude of the load P that can be applied to the truss, okay? So we got this truss over here that has a roller at point A, a pin connection at point E, and it's going to be loaded with this force P. But we don't want our members to suffer more than 5 kilonewtons in tension and 3 kilonewtons in compression. So the first thing that we need to do in order to solve this problem is to always draw a free body diagram. So let's go with our free body diagram. Okay, and what do we have? Then we got our truss that is going down. Let me leave a little bit more space over here. Then we got connected to A, then connected to B, C, D, and then last E connected to C. Okay, so that's our free body diagram. Then we need to apply our force P over here. Then what else do we have? If we have a roller at point A, that means that we're going to have a reaction force normal to that surface. If our surface is vertical, then normal to that surface is going to be horizontal. So we're going to have an A that I'm going to call X because it's in our X direction. Then over here at point E, what do we have? We have a roller, a joint. So in this joint, we're gonna have two reactions. Our reactions in X direction that I'm going to call EX, and also our reaction in Y direction that I'm going to call EY. Okay. Last, what I want to put in this free body diagram is, well, first our labels for each joint. This one is D, and last this is E. Okay. The only thing that we're missing in here is the direction angles, okay? So I need to say, hey, what's the direction of my force, our member? For example, AD, AV, or CD and CV. Now, if we pay attention over here in our big diagram, we can make a triangle like this in order to represent our member AD. Now, it's 1 meter going up and 2 meters going to my right. So, if we calculate this angle theta, so theta will be equal to the inverse tangent of opposite, so 1 meter, divided by adjacent, which is 2 meters. Okay, and then using our calculator, what do we get? So we're gonna do the inverse tangent of 1 over 2. That gives us 26.57 if we round it up. So 26.57 degrees. I'm gonna write it up over here. Okay, and then the other angle I want to get is this angle that in the direction known with respect to the x-axis that I'm going to call it gamma. Okay, so if we pay attention, gamma will be equal to inverse tangent of then our opposite, which is 3 meters, divided by our adjacent, which is the total of 2 meters. And let's see how much this is. So we're going to do the inverse tangent of 3 over 2, and that's an equal of 56.31. Okay, so 56.31 degrees. I'm gonna just write it over here. The gamma equals 56.31. Why did we need this angle? So these angles is just to know the directions of all these member forces over here. So we know that all these guys are in the direction of gamma with respect to the x-axis. So if we pay attention, all these make the same triangle. And then lastly, there will be the angle with respect to the x-axis of this guy will be gamma, okay? After knowing these directions, all I want to do first is to solve the entire summatory of forces with respect to these truss. So first, we're going to do the summatory of forces in the x direction. And what forces do we have in the x direction? Well, we got AX going to our right. So we got AX. What else do we have? We got EX going to our right as well. And that's it. All this should be equal to 0. Next, summatory of forces in the y direction. What do we have? We got EY going up. And then we got negative P going down. So negative P. And then this should be equal to 0. From here, we can conclude that EY should be equal to positive P. Okay? Now, from this one, we can also conclude that AX should be equal to negative EX. Okay? Last, if we want to solve for one of these guys, we're going to do the summatory of the moments with respect to one point. So the point that I'm going to choose is point E. Why that point? Because that point eliminates these two forces, so it's a little bit easier to do our moment. And then what do we have? Well, I got this force P. So if I were to connect this truss member in the middle like this, and then I have a force P going down, that means that this will rotate clockwise. So for me, the clockwise is going to be negative. It's going to be the distance. So what is the distance between my point E and this force P is 2 meters. So 2 meters. So I got 2 multiplied by P. And then the other force at that point E, it's this A over here. But in order to know that reaction, I'm gonna hold it like this, and then point E is there. And then if I apply a force in the middle of that truss, it's going to go counterclockwise. So I'm gonna assume my counterclockwise is positive. And what's the distance? Well, the distance between E and A is 2 plus 1, so that's equal to 3 meters. So we got 3 multiplied by AX, and all this should be equal to 0. If we solve for AX, we'll have that we move this negative 2p to the other side, so we'll have positive 2p divided by the coefficient that we have here, so divided by 3. Okay? So in this case, we know that AX is equal to 2p over 3, and then therefore EX is going to be equal to negative 2 over 3p. Okay? So we found the reaction of all of this, and we can simplify our free body diagram now here. Okay, so after solving for our reaction forces at A and our point E, then we can draw our new free body diagram, or without our updated values. So 2 over 3p over here, negative 2 over 3p if you draw in this direction, and positive p going up. So now we need to know how much forces with respect to p each member is applying. So, and if they are in tension or compression. So in order to do this, we're going to apply the method of joints that we have been using in our channel. And as I said before, the key part of doing this method of joints is to find the joints that have 2 or less unknowns. So we can check, for example, our joint A has 2 unknowns, which are the force FAD and AB. So we can start with our joint A. But if we also pay attention, we can always start with my joint E, because my joint E only has two unknowns also, ED and EC. So here we're going to start with my joint A, and we will keep on moving. So we have my joint A, and what do I have? I got positive 2/3P going to my right. Then I have my member force FAD, and then I have also my member force FAB. Okay? Now, the direction of these guys with respect to the x-axis is theta for these two guys. And obviously this one is just totally horizontal. So we're going to start doing the Summatory of Forces. Now I'm going to start doing the Summatory of Forces in the y direction so I can know how much this one is this one with respect to each other. So we got positive FAD going up multiplied by the sine of its angle, so theta, minus FAB, multiplied by the sine of theta as well, and this should be equal to 0. So if we solve for one with respect to the other, we will find out that FAD will be equal to FAB, because these sines of theta will cancel out each other. Now the next thing we gotta do is the Summatory of Forces in the x direction. And what do we got? Well, we got positive 2/3P plus positive FAD. Therefore, we got FAD times the cosine of theta plus the x component of FAB, which is FAB times the cosine of theta again, and this should be all equal to 0. Since we figured out this relationship that all these two are equal to each other, therefore I can combine these two into one single, so we'll find that we'll get 2FAD cosine of theta will be equal to, and if I pass this one to the other side of the equation, negative 2/3P. Okay? The last thing we gotta do is put FAD by itself. We'll get negative 2/3P, and then we're going to multiply by what? This 2 is going to pass to divide, so we're gonna have 1 divided by 2, and this cosine that's multiplying is also going to go to the other side to divide, so cosine of theta. If we plug our values in, leaving P alone, what do we have? So we're going to apply this. Negative 2/3 multiplied by 1/2 cosine of theta. What is theta? So let's not forget theta is 26.57. And we will find out that we got negative 0.373. So it's negative 0.373P, because we are leaving our P explicit over here. This negative tells us that these guys are in compression. So in order to save some board, I'm going to come here. I'm going to write our answers that we've been getting over here on top, and we get that my force AB is equal to my force AD according to this equation, and it's equal to 0.373 P in compression. So it's in compression. There we go. Okay, so we're good with this, guys. The next thing that we gotta do is the following joint. So from here we can do either joint B or joint D. So I'm going to stick with joint B. Okay, so this is my joint B, and what do we have? Well, if we look at my joint B, so I apologize, I am missing another member truss in here. If we look at our joint B, what do we have? I got AB that is coming this way, so force AB. Okay, then we got my force BC, and last I'll have a force going up, that is my force BD. Okay, that's all I have over here. And don't forget, this guy, it's also, with respect to the x-axis, it's also theta. Okay, same goes for this guy, will be theta. Okay, so we're going to apply our summatory of forces in the x direction, and what do I get? Well, I got negative. I got the negative x component of FAB, so negative FAB multiplied by the cosine of theta plus this guy that is going to my right, the x component of FBC multiplied by cosine of theta as well, should be equal to 0. Therefore, we can cancel my cosines and we'll figure out the FAB will be equal to FBC. Okay, so we know how much FAB is, so we already know how much FBC is. Last, we're going to do the summatory of forces in the y direction. And what do we have? Well, I got positive y component of FAB, so FAB multiplied by my sine of theta, plus I got FBD, plus the same y component of FBC, so times sine of theta should be equal to 0. But hey, here we go again. FAB is equal to FBC, so we can combine them together and we figure out the FBD will be equal to, and we pass them by the other side, negative 2FAB multiplied by my sine of theta. Okay, so what is this equal to? So we'll have negative 2 multiplied by FAB. FAB is equal to negative, because it's compressive, don't forget that we found the negative, 0.373 P multiplied by my sine of my angle theta, that it's over here. We're gonna take our calculator and we're gonna plug our numbers. Negative 2 multiplied by negative 0.373 multiplied by my sine of 26.57, and we will find out that it's equal to my force FBD will be equal to 0.334. I'm gonna put our 6 weeks to 3 significant figures, and this one is in tension because we got it positive. Okay, I'm going to write my answers over here on top again. And what do we have? Well, that FBC, it's also equal to 0.373 P in compression. So we got the same thing here. While my FBD, it's equal to 0.334 P in tension. Okay. So far, we have FAB, we got AD, we got BC, and we also got BD. So the next one that I'm going to do is going to do my joint D, so I can discover DE and DC. So here we are. I'm going to erase this since we know its answers, and we're going to draw my joint D. Solid joint D. Okay, what do we have for my joint D? So we're gonna have a member force going up, that is F DE. Then we got F DA. We also got going down F DV, and we got going diagonal my force DC. Okay? We're going to apply our Summatory of Forces in the x direction. But before we apply that, let's not forget that for these two guys, its direction is theta and theta. So we're done with that. And what do we have in the x direction? We got negative FDA. So we got negative the x component of FDA, which is multiplied by my cosine of theta, plus the positive x component of FDZ times cosine of theta, and this should be equal to 0. Therefore, we can cancel our cosines, and we'll figure out that FDA is equal to FDZ. Okay, so my force dA or AD, so if we stick to the nomenclature that I wrote before, this actually should be AD. So I apologize for that little mistake, but then we can figure out that this force AD is equal to my force DC. So therefore we also know the value of force DC. Last, we're going to do my Summatory of Forces in the y direction. And what do I get? I get positive FDE, minus, so I get negative FAD multiplied by my sine of theta minus FDV minus FDC sine of theta. And all this should be equal to 0. Okay? Now what happens? Do we got the value of FAD? Yes. Do we got the value of DC? Yes. What about DV? Yes, we got it as BD. It's the same little nomenclature mistake I make over here. So this is BD. Therefore, we got the value of this guy, and we can solve for my force D. Should be equal to the addition. If we pass this guy, will become positive, positive, and positive to the other side. So we'll have FAD sine of theta plus FBD plus FDC sine of theta. Okay, so we're gonna put our values in here, and what do we have? So I'm just gonna do this one. FAD is compressive 0.373. So we got negative 0.373 P multiplied by my sine of theta plus FBD. FBD, we got a tension, therefore positive 0.334 P plus negative, and DC is the same as AD. So basically what we can do is that we can multiply this guy over here in front. So negative 2 times, okay? Because AD is the same as DC. So if we put our calculator and we say, okay, I want negative 2 multiplied by 0.373 times sine of theta, 26.57, plus 0.334, we'll figure out that this value is equal to 0. So FDE it's equal to 0. Okay, so we found two more members. I'm gonna write them over here. My force DC equal to my force AD, which is 0.373 P in compression. And we also found that FDE it's equal to 0. Okay? So if we come here again, we figure out DC and DE. All we need is EC. Okay? So we're going to erase this again just to make some room, and we're going to do joint E. So joint, and what do we have for my joint E? We got, for this guy, we got positive P going up. We got over here negative 2/3 P. Then we got my forced DE. Let's not confuse the nomenclature again. And then this guy is my forced EC. That is the one that we need to find. So this guy with respect to the x-axis is gamma, and the rest are either totally horizontal or vertical. So we're good with that, and we're going to do the Summatory of Forces, and I'm going to do it in the x direction. What do I got? I got negative 2/3 P, right? Plus, I got the x component of FEC, therefore is multiplied by my cosine of gamma, and this should be equal to 0. So if I want to solve for my force EC, that will be equal to negative 2/3 P multiplied by 1 over my cosine of gamma. Okay? Why 1 over? Because if over here is multiplied, then over here you gotta go past and divide. And then if we plug our numbers in the calculator, what do we get? We're going to do the following. We're going to do negative 2/3. By the way, I did a small mistake. This negative comes here and pass positive. So a small mistake over here. So we don't get this negative anymore. So we got 2/3 multiplied by 1 over cosine of gamma. What is gamma again? 56.31. And we will find out that my force EC is going to be equal to 1.2 P. Okay? So we got our last member. So if we write our answers on top, what do we have? So the last member, FEC. FEC equal to 1.2 P in tangent. Okay. So our limits are 5 kilonewtons in tension and 3 kilonewtons in compression. Clearly, the member that is doing the most force is EC, which is 1.2 P in tension. Therefore, my FEC is our limiting member, and then we're gonna put it equal at 5 kilonewtons. That's the maximum it could apply. And if this is equal to 5 kilonewtons, then we can solve for my force P, my low P, since we know that FEC is equal to 1.2 P. Therefore, if we solve for P, we're gonna get 5 divided by 1.2. Don't forget the unit, this kilonewtons. And what do we get? Last thing, and we're done with the problem. So 5 divided by 1.2, and that will give us 4.16 kilonewtons. So we get 4.16 kilonewtons. Okay? This is the maximum forces that this truss can handle. Thank you guys for watching. I hope it was helpful, and I'll see you guys in the next one.